Again to the Theories of Everything program. I'm David Tao. Viewers, this is the third program in our series Theories of Catastrophes, in which we examine the origins and impact of catastrophes on our Earth, on life, and on our civilisation over the eons. In our first program we examined the impact of the cosmos at large, because it does have an ongoing, it not only had an impact in the early days of the formation of our planet, but it has an ongoing impact on our lives. There's a continuous stream of violent events. There's stars that are being born and dying, and as they die they become supernovas sometimes and eject vast amounts of cosmic matter, cosmic ions in the form of hydrogen ions, and also high intensity gamma radiation. There's also neutron stars, the stars that have run out of material to burn, compressed but not quite reached the supernova stage, but they impact each other. They also have various interactions with black holes, and in the process again released vast amounts of cosmic matter and radiation. And then there's our own sun. Our own sun, of course, releases magnetic flares constantly, which also have an impact on our climate, on our atmosphere and our climate, and on anything that's electronic in the neighbourhood, such as satellites and our space station, for example. And certainly all these forms of radiation and cosmic matter would be a risk to astronauts in the future, the lives of astronauts. Of course, during this time, at the early phases, from the very beginning, the Earth was bombarded by asteroids and comets and everything else from outer space. And this bombardment, of course, didn't allow an atmosphere to form initially. And at the same time, there were enormous upwellings of magma in the form of volcanic events. And this bombardment didn't sort of slow down until around about 4 billion years ago. And at that time it ceased or slowed down to the extent that early life could form in the form of early forms of blue-green algae and plankton. And that was around about 3.5 billion years ago. So viewers, at this point life is able to get a toehold on land at last, and because the land has been continuously forming from lighter granite type materials, feldspars that are able to float on top of the heavier basaltic material from the magma. So from the period from around about 4 billion years ago to 2 billion years ago, the land plates, tectonic plates as we now know them, are forming, but also the oceans are forming from water escaping also from volcanoes and perhaps from some comets. The atmosphere is forming and changing, largely hydrogen, carbon dioxide, some oxygen from early photosynthesis, but not very much, because plants largely haven't formed yet and didn't do so till around about 350 million years ago. But then from about 2 billion years ago, we have a proto-Gaia. We have an Earth that's starting to get its act together, starting to reach its sort of equilibrium, or try to, within its larger cosmos. It's got atmosphere, and it's got oceans, and it's got early land masses, and it's got some early life. And at this point, of course, scientists believe the early snowball events occurred. The aggregation of ice and snow to 2 or 3 kilometres deep, covering most of the planet. Gradually, over millions of years following the snowball events, carbon dioxide continues to escape from volcanoes deep underneath and gradually warm the atmosphere up, trap more heat, and so eventually the ice melts And it goes over the period of millions of years, of course, from minus 50 degrees centigrade to plus 50 degrees centigrade. And there are probably about 3 or 4 of these events, ranging from about 2 billion years ago, 750 million years ago, 650 million years ago. At the end of that time, life gets a spurt on. There's more oxygen around, the conditions are more conducive to life, the end of the snowball event, and it forms the first multicellular organisms probably, and the first Ediacaran organisms, the first bizarre multicellular organisms, early animal life in fact, around about 600 million years ago. And then the more complex little animals start to form, some in the sea and some on land. And at this point life begins and life struggles. Life is trying to survive the impacts that are still occurring. You've still got some meteors, you've got again huge variations in temperature. Life is developing to the point where it can sense the environment, it can sense the information gaps between itself and its environment, and tries to, through rudimentary sensory equipment and the very first proto brains, if you like, and nerve cells and nervous structures, tries to understand its environment and react to it and survive, because survival is what life is all about. And it does, except that every now and again there's a extinction event. There's some ginormous volcanic event which floods everything with magma, or else there's perhaps a hit from outer space, a supernova, the radiation again blasting everything, all the protection from the ultraviolet light disappears, major bombardment from meteors, of course, that happened in the 65 million years ago, the dinosaur event. There's probably about, again, 5 of these, it's calculated, extinction events from about 440 million years ago, 365 million years ago, 250 million years ago, 65, 70 million years ago. Life takes a king hit in each case, wipes out 60 to 90% of it in each case, but it struggles on. And, interestingly enough, comes back. And lucky for us that it does as well. And this is a huge enigma of evolution. It comes back in similar forms each time, because that's the form that can best fit its physical environment, with minor variations. Well, by the time of the dinosaurs, of course, there's quite complex life. The dinosaurs largely disappear or morph into large birds like emus and cassowaries and smaller birds. But many of the other organisms reappear in very similar form, including the mammals, the early mammals from which our lineage began. And so, viewers, we're coming into the modern era at this point. Around about 1 million, 2 million years out, and Earth settled into a cycle of glacial periods and interglacial periods. The glacial periods aren't as bad as the snowball events, but they're still pretty severe, and they make it very difficult for hominids and humans to survive. We get into a cycle of around 100,000 years of cold and interglacial periods of 10 to 20,000 years during this period of warmer, benign weather, when life can get a move on again. During that time, that's when the big shift came, and that's when our civilization began, around about 15,000 years ago. Because that's when they learned to farm, and we've had previous programs on this, that's when they learned to cultivate early crops, domesticate animals, and build villages, towns, and eventually cities. And of course this is when they really felt the effect of these natural catastrophes, because they built on floodplains and coastal areas, across earthquake areas prone to earthquakes, fault lines, and they had absolutely no idea what they were doing and what was about to befall them. So we see, viewers, that the early civilizations began to develop around about 5,000-6,000 years ago, and the early empires also around from about 4,000 years ago, primarily in the Middle East. Mesopotamia, current-day Iraq and Palestine and Turkey. Empires such as the Akkadian Empire around about 4,500 years ago. in South America, in Bolivia and Peru, around about 1,000 years ago, 1,500 years ago. Also in Mesoamerica, Central America, the early Maya Empire, around about 250 AD. All these empires were very sophisticated. They had developed language, they had developed number systems, hieroglyphs. They had developed methods, of course, of farming and, most importantly, of conserving water for hard times. Irrigation channels, mini dams, very clever systems, in fact. These were very sophisticated civilizations, and they'd had their hard years. They'd had years of drought, not long periods generally, but long enough to know that they had to conserve water, just as we have to learn again today. So, but basically they couldn't withstand prolonged droughts. And the current consensus of opinion seems to indicate that many of these early civilizations, including, for example, the Minoan Empire and Crete, basically were overcome by mega droughts. And these droughts could last, say, from 5 to 10 years, but there were mega droughts that lasted 100 years. And their irrigation systems just couldn't cope with that. So it's only been recently understood that the El Nino effect probably kicked in about 6,000 years ago, and that was the major cause for most of these droughts that killed off early empires. Viewers, it's only in comparatively recent times that we've been able to understand the variations in climate, the interactions between the oceans and the atmosphere and the land and vegetation and life that can trigger changes in climate. Early humans, early empires didn't have that understanding. They started to clear land right from about 6,000-7,000 years ago for crops. Right from that period, they left a signature, a human signature, in the form of increased carbon levels on the planet. Viewers, it's ironic that the same problem, the lack of water in the time of drought, that led to the downfall of probably many early civilizations, is confronting our civilization today. Today we have vastly greater knowledge of technologies and an understanding of climate, and yet the same problem is there, probably magnified. We have 6.5 billion people on this planet now, compared with a couple of 100 million humans that populated the earlier periods. We have waterways that are mostly polluted, that have been fragmented by dams for power generation. In those times, water was pristine and flowed freely. But in the face of a mega drought, we are brought back to reality. We are brought back to the reality of finite resources. But finally, viewers, the penny has dropped. Over the past few years, particularly, there's been an increasing crescendo of demand. Demands from not only the green movement, but from local communities, from the business community, for immediate action to prevent these doomsday scenarios from occurring. I've run several shows in the past on the state of the planet and also on ecosystems. But there's been hundreds of documentaries and hundreds of publications, hundreds of books written defining the obvious, defining the major indicators that everyone can now see around us relating to climate change, global warming. Huge extreme events, extreme droughts, which we're facing in Australia, but all over the world as well, particularly in places like Africa. Extreme flooding, extreme hurricanes, and tornadoes. All these things have ramped up, all these indicators have ramped up. Basically, the oceans are rising as well, and if they continue to rise from around about 0.5 metre to 1 metre by the end of the century, they'll displace about 100 million people from the coastal regions. There'll be no more ice left on the polar cap. That has huge ramifications because ice reflects light and heat. Darker oceans absorb it. There's a major hotspot in the subarctic areas like Siberia and Greenland and northern Canada, where the permafrost is melting and releasing vast amounts of methane in the process. Loss of biodiversity is, of course, a major indicator. Not only magnificent animals such as tigers, of which probably only about 500 remain on the planet, but also elephants, lions, jaguars, cheetahs, desert antelope, major sharks, rays, amphibians, frogs. All these animals are struggling to survive, not only from the predatory tactics of humans, but also because of global warming. They can't adapt fast enough to their environments to survive. Generally, though, with the larger mammals, it's because we've cut down their habitats and we've hunted them. The World Conservation Union has a red list, a list of species that are at risk from extinction and probably will go extinct in the next 50 years. It lists 2 out of 5 species facing extinction, 16,000 plant and animal species in all, 1 in 8 birds, 1 in 4 mammals, 1 in 3 amphibians, most fish species. This, of course, has enormous ramifications. It means that all our major ecosystems will start to crash, and if they crash, we crash as well. One of the really disturbing aspects, viewers, of the state in which we now find ourselves, and one which I think has been vastly underestimated by some scientists and commentators, are the runaway effects of global warming. We've passed through a number of thresholds, or tipping points, without really realising it, and they're going to have a profound effect on us in the future. No matter how much we cap carbon emissions in the future by 550 parts per million by 2050, or reduce them by 30% below 1990 levels in the next 20 years, these runaway effects have gained so much momentum that they'll be unstoppable, at least for a long time. They include, for example, that thawing of the permafrost in the subarctic regions that I mentioned. 70 billion tonnes of methane will be rapidly released over the next decade, or a large proportion, and double the amount of carbon released into the atmosphere and increase global warming by up to 20%. The melting of the ice, both in the Arctic and Antarctic, of course, will have also profound runaway effects. It'll be impossible to prevent that fresh water from impacting the Gulf Stream, for example. The Gulf Stream is an important part of the North Atlantic conveyor belt that brings warm water and with it warm winds to the Eastern America and Western Europe every year, and that relies on salty water descending and pushing and going back down to the equator and pushing the warmer water northwards. If that conveyor belt, if the Gulf Stream is shut down, it could lead to a drop of 3 to 5 degrees centigrade in temperature within a period of a decade, and cause a mini ice age to those northern regions. This is not science fiction, but fact. There's also the acidification of the oceans that's occurring at a very rapid rate. The oceans absorb about 1/3 of carbon emitted in the form of carbonic acid, and it goes down to about 2 kilometres. It affects regions of the ocean down to about 2 kilometres. And of course affects all calcium related compounds, including the shells of sea animals. So basically that will have an ongoing profound effect, the acidification of the oceans, which is going to be very difficult to stop. And then of course there's the dislocation of the ecosystems from the phytoplankton up. At the end of the last glaciation, 15,000 years ago, there was enormous dislocation. All the ecosystems had to refine themselves, readapt. And because of the speed up of warming now, all those ecosystems are breaking down, apart from the loss of species. They're out of sync. The birth of caterpillars in relation to the budding of new leaves on plants they eat. Then the hatching of birds that eat the caterpillars. They're hatching too early or too late. They have to readjust. That takes time, but they've got no time. So the fitting of ecosystems is a very complex, delicate affair that again takes a long time to achieve. And when it's disrupted, it cannot find itself again for a long time. So basically, these are runaway effects that will have to be addressed if we're going to survive. How we address them is going to be extremely complex and very, very difficult indeed. So viewers, what's to be done? Well, all the obvious things to start with, reducing the global warming gases, carbon dioxide, methane, etc. from our atmosphere as fast and as far as possible. Smarter techniques of reducing the emissions from power stations, from vehicles, etc. Scrubbing carbon dioxide out of those emissions, sequestering it, converting it back into fuel, back into hydrocarbons again. There's some very good techniques, good technologies on the way to do that. Gasification of coal, that improves its energy output and reduces carbon emissions as well. Increasing use of renewables, and wind power, as I've said in previous programs, is now having a significant impact and an economic impact on the grid. And talking about power grids, the existing power grids, the existing power generators, transformers, distribution chains to distribute electricity are very inefficient and are mostly using older technologies, older analogue technologies that don't take into account the latest digital improvements that have been made in almost every other industry, computerised improvements that have been made over the past 50 years, where they're still using old, relatively inefficient technologies. Of course, conservation is the other major aspect to this, is the other key ingredient. Conservation of energy, conservation of water. Vast amounts of energy are just lost again from the electricity grid through to factories. Probably about 50% at least is lost along the way. So better technologies there. Conservation of ecosystems, prevention of further logging of the Amazon regions and the regions of Africa that still contain some of the most pristine and important ecosystems in the world, but reef systems as well, desert systems, Arctic systems. All these systems have to be protected. Certainly drilling in the Arctic should be banned. Drilling for oil in the Arctic should be banned. So these are fairly obvious things, but obviously they'll have to be strengthened enormously if we're going to survive. But a lot more needs to be done as well. And the third part of the equation is global cooperation through treaties, benchmarks such as Kyoto, capping emissions, putting a price on the heavy polluters that governments such as the US government and Australian governments are so keen to protect. The generators of carbon and one of the heavy users of carbon, such as the aluminium industry, for example. Short-term protection that in the long term will kill our planet. So the arrogance of those governments is enormous. Global cooperation in all areas, conservation, new technologies will be absolutely essential. As the Stern report that was just released the other day has said, this is a report that looks for the first time at the economic impact of doing something or of not doing something. If we put in place all the new technologies, all the improvements, it'll cost business, it'll cost us about 1% of GDP per year. If we don't put them in place, it'll cost between 5 and 20%. In other words, we'll end up in another huge depression, and worse. Chaos would be more, anarchy would be closer to the mark, I would say, once economic systems start crashing to that extent, as well as ecosystems. So the cost of not putting in place these controls, and the cost of not having global cooperation, will be beyond our imagination to understand. It will mean basically the death of our civilization as we know it. So viewers, if we are to avoid the biggest catastrophe that's ever faced our civilization, we're going to have to up the ante considerably. We're going to have to become a lot cleverer, a lot more creative, and a lot more cooperative than we ever have been in the past. It's too late now to rely just on experts, just on governments, just on technology. We're going to have to rely on our own intelligence, the cooperative global intelligence of life on this planet, and perhaps the only intelligent life in the universe. We're going to have to take responsibility, in other words, for our own survival. I'm David Tower, and you've been watching the Theories of Everything program again. I'll look forward to seeing you again next week.